Thank you for joining me in this series of Ask the Business Data Analyst. I am Priya Telang, a senior data analyst with a diversified professional experience of 10 years in various MNCs. I am passionate about using data to solve problems. I am a Tableau desktop specialist and IIBA certified business data analyst. So, the question for today is, what is a data science project and how is it different from other projects? Now, let us first understand what is data science. So, data science is an iterative process involving various techniques to extract value from data to solve business problems. It has become an essential tool for any organization that collects, stores, and processes data as part of its operations. In today's context, data science heavily relies on machine learning and data mining. Data science is commonly used to solve different business problems. For example, classification, fraudulent transaction or not, clustering, group customers based on their purchase patterns, recommendation, which movie would the customer like to watch next, or prediction, predicting the interest rate of a loan. So this value extraction from data is done systematically using a framework. We will be looking at a widely accepted framework called CRISP-DM, Cross-Industry Standard Process for Data Mining. This provides a structure to our thinking about handling data analytics problems. The outer circle indicates that the process does not end with the deployment, but can lead to new projects, maintenance, upgrades, or learnings for the next projects. So let us explore this in detail. The complete data science cycle revolves around the business problem. The key to great success is a creative problem formulation, converting the business problem into one or more data science problems. It is essential to know the underlying models and business practices, the context and the business processes generating the data. Without a well-defined and well-understood problem statement, it is impossible to select correct data sets and algorithms for our analysis. Take an example of predicting if borrowers will pay off their loans on time or not. All details related to the borrower, like the customer demographics, the annual income, current liabilities, credit score, etc. need to be assessed. Thus, the business problem statement, stated in simple terms, can be formulated as, can we predict if a borrower will pay off their loan on time or not? The data, which is the available raw material to build the solution, must be picked very carefully. In the above example, say suppose we could get data for borrowers with an annual income of 25,000 rupees. Now, this is an important feature for or data variable in predicting loan payment. In the later stage of modeling, the model will not predict correctly for incomes less than 25,000 rupees. So the underlying issue here is not capturing sufficient data representing the real world. A fundamental understanding of the business domain is essential to avoid such failures. We may collect data as CSV files, text files, relational databases, or obtain data from the internet using web scraping. Another option is to connect to third-party APIs. So websites such as Facebook and Twitter allow end users to connect to their web servers and scrape their data. Many times, we may not have suitable data. In that case, we can consider buying or creating it through a survey. In this phase, we also look at how we will store this collected data. Also, exploratory data analysis is used to better understand and prepare data in a way suitable for advanced analysis. It is helpful to understand distributions and interrelationships between variables. So data visualization is widely used in this process. For example, we can use a histogram for annual salary distribution and see the range where most of the salaries in our dataset fall. Or a scatter plot of the relationship between credit score and interest rate. Using this, the data scientists understand patterns that enable them to decide which machine learning technique is likely to perform better. Next is data preparation. This is the most time-consuming but critical step before jumping into data analysis. Some of the most common tasks performed in this phase are data merging. So majority of the times, we will have to integrate data from multiple sources by merging the data sets. We will then have a single source of truth. That is, all the required data assembled in one place. So in the above example, demographic data, loan information, bank account details, etc. will be collected separately and merged. Next is data quality. So data quality is the most significant point for anyone working with data. Multiple things are checked for assessing the quality of data, like incorrect or corrupt values. The data may have incorrect values, like the credit score, which ranges actually from 300 to 850, but is incorrectly recorded as 900. Or during data merging, annual income from the United States and Germany may look different because the comma is replaced by decimal in German currency. So 60,025 would be represented as 60.25. Missing values. So some data might be missing, like a bank credit score in one of the accounts. Most of the models will not perform well with missing values. Also, it may affect mathematical calculations. So correct replacement is important. Detecting outliers. So outliers are basically anomalies in the data set, extremely small or very big values away from the expected range of values. So if we find that a few people's reported annual income values are tens of millions, then we know they are incorrect. Or if the annual income is 60.25 as we saw when merging with German data, this outlier is because of erroneous data capture. So outliers mislead the training process of the model and affect the accuracy. Next is data transformation. The powerful analytical tools that we often bring in, they have some restrictions in reading and processing data. So usually the format will be different from the naturally produced business data. Let us explore some typical examples. So the first one is feature selection. Now, not all the collected data fields may be useful for our model analysis, right? So we will select only a few fields which are actually important. We will also create some new ones using the existing fields. The final set of fields is called features. These features will be the input to the next model. Data type conversions. So many models can handle only numeric data. So say suppose you have the credit score as poor, good, and excellent. We may have to convert them into a numeric score by encoding a dummy value to each score. Say poor is represented as 100, good as 200, excellent as 300. So here basically we are converting the categorical data into numeric data. Next is feature splitting. We may have the state and country names clubbed in our incoming data. But for our regional analysis, we may want to split and separate the state and country into two different columns. And lastly, normalizing. So some categories may have different ranges of values than others. Some products may be purchased more frequently than others. Example, clothes may be purchased more frequently than electronic items, right? So here we normalize the values so that the quantities of all products fall in a similar range. This helps ensure that products that sell more do not add a bias. Data modeling and evaluation. So this is the stage where the real magic happens. Data science algorithms derived from statistics and math are used to automate tasks by building models. We will be covering commonly used algorithms in another video. The business problem and the data available dictate the model selection process. Training and test data sets, right? So this is a very common way of training and testing the model. So the standard thumb rule is to split the data with features and known output, whether the loan is paid or not, yes or no, into 80% as trained dataset and 20% as test dataset. So for example, say our model only uses two features, credit score and annual salary, to predict whether they will pay the loan on time or not. The model will learn how to do this prediction using the trained data. We will then assess the model on test data to see how the model is performing by comparing the actual and predicted results. We keep fine-tuning the model until the desired accuracy is reached. Here are some of the basic steps performed by the data scientist. So basically, we build the model using training data. Then we assess the model using test data and fine-tune as required and then finalize the model. Once the model has reached desired accuracy, the insights or relevance to the original business question, the business impact, risks, right, and much more have to be communicated to the business decision makers. Business visualizations and data storytelling are an essential part of this process. Deployment. Now, once the decision is made to implement the changes, we move on to the deployment stage, where our model goes live or becomes production ready to work in the real world. The results of the data science process have to be assimilated into the business process, usually software applications. And once implemented, the models have to be monitored and maintained. The model in our example can now be used to predict whether new borrowers will pay their loan on time or not by integrating it into the actual loan approval process. Though we have many algorithms available, the real skill lies in the data scientist's ability to proficiently transform the business problem into a data problem and then apply the suitable algorithms. The CRISP-DM model provides a very simple yet effective outline and sequence of the phases in a data science project. Of course, the sequence of the phases is not rigid. Moving back and forth between different phases is always required. Do you also want to work on such exciting projects? Check out our training programs on Certification in Business Data Analytics by IIBA and Exploratory Data Analysis course. I hope you enjoyed this introduction to how data science projects work. Let us know your questions in the comments and we will take them up in the next episode. Stay tuned for more interesting videos in the learning series. Thank you for joining us and good luck.